Right, welcome grade 10s, topic 1, which is algebraic expressions, but first we're going to look at number systems and classification. Right, I'm Mr. Simons. This is Simons Maths, and I hope together we can master and improve our maths significantly. There's a lot of basics we have to learn, but I've done it in order. Hopefully you will be able to follow using your class textbook and read through the problems and understand what I've done. So without further ado, let's start with the number system. Alright, so in the number system, right, work we must know, we must be able to classify the real number system. And do a separate lesson on converting decimal fractions to common fractions. When I have a lesson on rounding off, approximation and estimation, and establish between which two integers are sad line. So those are the basic 4 items that you have to cover under number systems as part of your classwork. I'll be doing it here with the hope that I'm assisting and helping you. Right, so for grade 10, 11 and 12 we will work with the real number system. We use the symbol R to indicate real number system. So the first number system we discovered is called natural numbers, also known as counting numbers. You know, when we count trees and cars and so on, we always start by 1, 2, 3, 4. We can't count a half a car, etc. So natural numbers contain no fractions. It starts by 1 and just continue increasing by 1. Symbol for it, n. Whole numbers, to make the natural numbers whole, we brought the value 0 in. So yeah, they always say there was a guy that decided that somebody did such a bad job that he wanted to pay him nothing, so he designed the symbol 0. Not sure is it whatever race or culture. I might not go on, not to offend anyone, because some people take every joke serious. But whole numbers simply start by 0 and increase by 1, so 0, 1, 2, 3, 4. Integers is simply my whole numbers and natural numbers, positive and negative. Right? Please don't get confused when we say minus half. It's not an integer but a rational number. So integers, symbol Z, minus 3, minus 2, minus 1, etc. Continue. Alright. Fourth, we have rational numbers indicated with symbol Q. These are numbers that can be written as fractions, a over b, where a and b are integers, but b not allowed to be 0. Ne? If we divide by 0, undefined. I assume you still remember that from grade 9. So there, rational numbers, minus 4, minus 1.5, minus 0,730, 0, etc. Alright, even recurring. Alright, so rational numbers include proper and improper fractions, terminating and recurring decimals. Say irrational numbers, it's Q with a small prime number or dash on the top, and it's numbers that cannot be written in the form a over b. So square root of non-perfect squares. Alright, so normally square roots of all non-perfect squares that have non-recurring decimals, so square root 3, square root 5, square root 7, etc., they are all considered irrational. Pi, irrational. Right, and there you see 1, 2, 0, 1, 2, 1, 3, 1, 4. Continuing in that list, there's nothing that's recurring, so therefore irrational. So in short, 6,421 ends by 1. This is referred to as a finite decimal fraction or a terminating fraction. You see there? Terminating fraction. Right, 1373737 will continue like that, and that's called a recurring decimal fraction. So finite and recurring form part of rational numbers. Therefore, terminating and recurring rational numbers. However, if I write 6,421 ... it is infinite, meaning non-recurring decimal fraction and therefore considered irrational. Right, so don't get caught out with that. Right. So that in short is the number systems and the things that we must be able to classify, the different types of numbers. Alright, we also have what we call non-real numbers. These are square roots of negative values. Right, they form part of imaginary numbers, which is not part of the real number system. Therefore, we just say non-real. Other types of numbers that we assume you still remember, prime numbers. numbers that only have two factors, so 2, 3, 5, 7, 11, etc. Still remember, assume you remember your prime numbers, but they only have two factors, the number itself and 1. Composite numbers have more than two factors, so 4, 6, 8, 9. If you take 9, 3 goes in 9, 9 goes in 9, 1 goes in 9. So there is more than two factors. Perfect square numbers, reason why we say square, because square, all the sides are equal, and to find the area we multiply two sides. Let's say perfect square, 1 times 1, 2 times 2, 3 times 3, etc. But 1 times 1 is 1, 2 times 2, 4, 9, 16, 25. And as part of our work for thing, we need to know up to 13 squared, which is 169. Square root is simply the reverse operation, so square root of 1 is 1, square root of 4, 2, square root of 36, 6, etc. Perfect cube numbers is simply 1 times 1 times 1, 2 times 2 times 2, and I assume you know cube all 6 sides are the same length, so to find the volume we would say length times breadth times height, but same value. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 4 times 4 times 4, 64, etc. And you are required to know up to 7 cubed, which is 343. Cube root, simply reverse operation, so cube root of 1, 1, cube root of 27, 3, cube root of 2, 16, 6, etc. So that's just your other numbers. Now I've just documented some basic problems that you should know and understand to test and also to improve your knowledge of number systems. Alright, so in the first problem we want you to classify. This is more in line with how we ask it in grade 9. Same, the number 4, we assume you know is a natural number. It also forms part of the list of whole numbers. It's positive, it's an integer. Can be written as 4 over 1, therefore a rational number. It's not irrational, so it's either rational or irrational. It's considered real. 5 over 8, not a natural number, not a whole number, not an integer, it's a fraction, right? So therefore considered rational and real. Pi, we should know straight away, is irrational. They've gone over a billion digits now. Still haven't found anything that's recurring. So pi, irrational and real. Negative 15, not natural, not whole. Can't count negative 15 in our society from what we see of basic counting numbers. It's considered an integer. Can be written as negative 15 over 1. So therefore, a rational number and real. 0. Considered a whole number, not a natural, integer, rational, and real. 0.23 is a finite value. It's terminating at 3. So therefore it's considered rational because I can write it as 23 over 100 and it's considered real. Square root 5. 5 is a prime number, not a perfect square. So straight away it's irrational and real. Square root of negative 3. Because it's negative, we can't find the square root of that. It doesn't form part of the real numbers, so therefore non-real. However, cube root negative 64 would become negative 4. So negative 4 is an integer, rational, and real. Square root 64 is 8, so therefore 8 is natural, whole, integer, rational, real. Fourth thing. 9.45 also terminates after 5, so therefore it can be written as 9 and 45 over 100, so therefore it is rational and real. And 1.0909 also terminates, so therefore it's considered rational and real. That's just basic classification so that we see whether you know which number is which. Take note, we don't need to write out for you. You need to know n represents natural numbers, n with the O represents whole numbers, z integers, q rational numbers, q prime irrational, r real, and then you need to know what's non-real. Right, in problem number 2, identify the following numbers as real, rational, integer, natural, irrational, or no numbers. You may use more than one term for each number, so we can give you a list. So 0 over 5, if I divide is 0, that would give me 0 is a whole number, it's an integer, rational, and real. Negative 5, negative, it's an integer, right? It's rational and it's real. 0.38 terminates, so therefore it's rational and it's real. Negative 0.76 terminates, so it's rational and real. 5/9 also rational and real. 0.9 with a dot on top recurring means 0.9999. That's also considered rational and real. 9.32 is the same as saying 9.323232, continuing on indefinitely. So that also is recurring, so it's rational and real. Square root of 15, not perfect square, therefore irrational and real. So that's the second way we can ask you to classify. Alright, one of our favorite exam questions when it comes to classification is given to you in this format. So we say if L equals square root x plus 6 divided by x minus 5x plus 1, for which values of x is L real. So by now you saw if this square root is negative, then we say it's non-real. As long as everything under the square root is positive, it's considered real. So for positive items, they will always be greater or equal to 0. So when it's greater than 0 is plus 1, plus 2. So therefore positive. So x plus 6 greater or equal to 0. If I take 6 over, x greater or equal to negative 6. Alright. In that list, if we continue, we're going to get 5 and negative 1. Remember, x can't be 5 because 5 minus 5 gives me 0. X can't be negative 1 because negative 1 plus 1 would give me 0. Anything divided by 0 becomes undefined. Alright, so for which values of x is L equal to 0? So L can only be 0 if the top is 0. If the bottom is 0, undefined. To make the top 0, I would say square root x plus 6 equals 0. If I square both sides, I simply left with x plus 6 equals 0. If I take 6 over, I have x equal negative 6. For L to be undefined, the bottom must be 0. So x minus 5 times x plus 1 equals 0. According to zero factor law, so if I take minus 5 over, x equal 5. If I take plus 1 over, x equal minus 1. For it to be non-real, remember the square root must be negative, so we say x plus 6 less than 0. All values less than 0, minus 1, minus 2, etc. So therefore I say less than 0. Take positive 6 over, it gives me x less than negative 6. Right, so I hope you enjoyed your introduction to what we will be doing. I wish you nothing but the best. Continue practicing. Together we will have a successful year. Promise you that. Those of you that's prepared to work and continue striving to be successful.